All right, let's go through our notes for Unit 9, Lesson 16. For this one, we're going to be graphing rational functions using the domain, vertical asymptote, horizontal asymptote, slant asymptotes, holes, all those different pieces. We're going to put it all together. And so first off, we're going to start off with the HA because I don't want to factor first. I just want to look at the degrees. And so for the horizontal asymptote, the degree on top is 1. The degree on bottom is 1. They're equal, and so when they're equal, we're going to look at y equals a over b. A is the leading coefficient on top, b is the leading coefficient on bottom, which is 1 over 1. So my HA is y equals 1. So I'll go ahead and make that horizontal asymptote, which means there's no slant asymptote. Everything's already factored, nothing cancels, so there's no holes in this graph. My VA, I set the bottom equal to 0, x equals 1. My domain's gonna be all real numbers, but x cannot be 1. And so there's my vertical asymptote. And as far as graphing up from here, we're gonna go into the calculator. And so we'll put in x plus 2 on top, x minus 1 on bottom. And there's what the graph's going to look like. And let's just get a few points on either side. So 1's my error, so I'll get 3 points on the left and 3 points on the right. So we've got 0, negative 2, negative 1, negative 1/2, and negative 2, 0. Now on the other side, we've got 2, 1, 2, 3, 4. 3 is 5 halves, which would be 2.5. 1, 2, 3, 1, 2.5, and then 4, 2. So there's the graph for number 1. All right, number 2. Again, we'll start with the HA. So the degree on top is 0. There's no x's. The degree on bottom is 1. On this one, the numerator is less than the denominator, which means my HA is y equals 0. Which means there's no slant asymptote. Again, nothing cancels out. My vertical asymptote, if I set that equal to 0, is x equals negative 2. And my domain will be all real numbers, but x cannot be negative 2. And so on this one, we could go into our calculator, or we can use our transformation form because there's no x's on top. So this one has a vertical stretch by 3, which means we're going to go 3 away from the asymptote, 1, 2, 3. And then where we usually go 2 away, we'll multiply by 3 to go 6 away, so 3, 4, 5, 6. And then where we usually go 1/2 away, we'll go times 3, which would be 3 halves. But you could always put it in the calculator to see what it is as well. You'll get the same thing, 1, 2, 3, 4, 5, 6, and then 3 halves. All right, going on to number 3. On number 3, on this one, the degree on top is 2, degree on bottom is 1. So on this one, the n is greater than the d, which means that there is no horizontal asymptote, which means we do have a slant asymptote. So we'll go ahead, set this equal to 0, so x equals 1. So when we do our synthetic division, I'm going to put 1 in the box. And on my coefficients, I've got 1 and then 0 and 0. So we'll drop down the 1, and then we'll multiply. And so 1 times 1 is 1. Add those together, we get 1. Multiply, we get 1. Add those together, we get 1 again. That's my remainder. So this is x plus 1 with a remainder of 1. This is my slant asymptote, y equals x plus 1. So my vertical asymptote is x equals 1. My slant asymptote is x plus 1. So that means our y-intercept is 1, and we're going to be going with my slope of 1, up 1, right 1, up 1, right 1, up 1, right 1, all the way through. So I'll draw that slant asymptote. All right, so my domain is all real numbers, but x cannot be 1. And nothing cancels out, so no holes on this one as well. So we'll go into our calculator, and in our y equals, we'll put x squared over x minus 1. And so here's what the graph looks like. And if you wanted to see as well, if I were to put in the slant asymptote x plus 1, we can see that the graph is getting close to that red line, and it even looks like it's touching, but it's not touching. It doesn't cross that line. That's the asymptote that it's approaching, but not touching. And so let's get a couple points on either side of that 1. And so we've got 0, 0, -1, -1/2, and -2, -4/3, which is like -1 1/3. And so we're going to get closer and closer to that dotted line, but not quite touch it. And again, we'll get closer and closer to the vertical asymptote, but not touch it. And on the other side, we've got 2, 4, 1, 2, 3, 4. 3 is 9/2, which would be 4.5. And so right up there. And then we've got 16/3, which would be 5 1/3. So you get closer to the slant asymptote, close to the vertical asymptote, and that one's done. And the last one, number 4. The degrees to start off are the same. They're 2 and 2. And so we're going to do y equals a over b, which is -3 over 1. So my HA is -3. 1, 2, 3. There's no SA on this one. Then we'll factor this, so we can take out a -3x on top, which is going to leave me with x minus 2. On bottom, we can do difference of squares, x plus 2, x minus 2, which means those cancel out, so there's a hole where x equals 2. The remainder one's going to be my vertical asymptote, x equals -2, so my domain's going to be all real numbers, but x cannot be either one of these, the whole or the VA, so plus or minus 2, because x doesn't have value at either of those. And so now to find where the hole would be, I'm going to plug in 2 with what's left over. So -3 times 2 over 2 plus 2, which is -6 over 4, which would be -3 over 2. So there's going to be a hole at 1, 2, and -1 1/2 right there. So I'll put an open circle right there where the hole would be. Get an asymptote at x equals -2. And then we'll just go to our calculator to get the rest of the points. So -3x squared plus 6x over x squared minus 4. And if you want to, you can put in your simplified one as well, -3x over x plus 2. So we see they're the same graph. And then we'll go to our table. And so one thing that's nice when you put in the simplified, you see where the hole is, which that's the same thing we got. We can see it in our table as well when we put in the simplified version, but I'll go on either side of my asymptote. And so we've got -3, -9, -4, -6, 1, 2, 3, 4, 5, 6, and -5, -5. And then for the other side of my asymptote, I've got -1, +3, 0, 0, and 1, -1. And then we're going to touch, we're not going to go all the way through the hole. We're going to touch the hole and then go out on the other side. There's that hole in the graph right there. All right. And that completes these notes. Make sure to let me know if you have any questions.